Hello, welcome to Reviews. This is the second part of the Sharp X1 repair. Now, last time we put the new power lead on the power supply. We did a bit of checking as well. Mostly we disassembled the X1 because it's a hell of a machine to disassemble. But we also obviously investigated what damage there was, so we knew what we had to do. It's not terrible. There's it's definitely had a whack on one side, which has broken some of the plastics and bent some of the metal, but this thing is built like a tank, so the internals appear to have been held up quite well to that abuse. So the idea today is we test the power supply and we see if we can safely get this thing at least powering up to see what happens. We should be fine as long as the voltages are correct. We should be alright. Anyway, let's get on with it. Right, here we are with the power supply on the bench. So, although we have replaced this power lead, we don't actually know if this power supply works. And so, as always, with all these things, we have to test to make sure we're getting at least similar voltages to that we expect. We don't know entirely what all these voltages are, although we do have a little bit of a heads up from Leaded Solder in my Discord. We know this one here is basically the power switch, so we can bridge those to get the power supply started up. And I think it was this one he said, this white one here is the 5-volt standby line. So if you don't know, power supplies certainly in most PCs and certainly modern ones, when they're powered up but the machine's not turned off, they don't give out obviously all their voltages. So these, which are the disk drive ones, they've got like 12 volt, 5 volt lines. They won't be high, they won't be active while the machine isn't actually turned on, even when it's powered up. But the power switch, which is usually a soft power switch, needs some voltage to get things started, and so they have what they call the 5-volt standby line, which is always on. And so that's what this one will be. So we can test this in two different ways. We'll test it first of all without trying to power it up, and that means we'll be testing this standby line here to see if we're getting 5 volts off of it. Then what we'll do is we will bridge this to hopefully kick this into play, and then we can test the rest of the voltages. So this is presumably going to be 5 volts and ground, I will assume, and just because of the coloration. And this, if it's anything like a normal disk drive, this will be 12 volts, this will be 5 volts, and these two in the middle will be ground. Certainly the colours are correct, so it's a good sign it will be. Now, we don't know what these will be. If the coloration is correct, then the yellow will be 12 volts, and that will be ground. That will probably, I assume, be a minus voltage, the blue wire. What kind? We don't know. But we will test it all the same. And the same with this one as well. That looks like 12 volts and ground. So, well, I mean, the first step is to see if we can plug it in without it blowing up. And to do that, it's obviously a Japanese power supply, so we have a Japanese step-down converter, so we don't put too much power through to it. Undo this. It's all wrapped up because it was on that Japanese N64 power supply, so we'll undo that. The power supply was taken apart so we can get this lead, but it is done in a way that I can put it back together if need be. Although I will obviously have to reconnect the end that I cut off. Right, so what we're going to do is then we're going to, over here I have my power banks which have switches. Very useful when you're repairing machines. So we'll leave that switched off for now. Right, so in the middle of our heat-proof mat, let's move things aside that we don't want to particularly be burned up, me especially. Right, I've moved things around a little bit, so you should be able to see the fan, which will hopefully become important later, and the multimeter, which is set to DC voltage mode. Right, okay, well, I think everything is moved out the way that might be damaged if something happens horrendously with this. The power switch is off on the side. Let's turn the power on over here. No smoke so far. I'm going to use, I know this is, you know, cowardly, but I'm going to use the toothbrush to turn the power on. Oh! Okay, I wasn't actually expecting the fan to turn on, because it would be in standby mode. Never mind, let's check some voltages. So, first of all, we have this one, which should be our standby 5 volts. So, we touch ground. Hopefully that's ground. We'll find out soon. And there. Oh, I'm getting nothing. Let's try from the back in case we're not making... Oh, 5 volts. There we go. Pretty much on the button. Right, we get anything from this one, which should also be 5 volts. We are, which is interesting. That means that this considers itself to be on stand. Maybe okay. So maybe I'm guessing the button is the other way around. So if it's low, it's on. So the switch will turn it high to turn everything off. Right. I think that's probably This is the X68000 did a similar thing. Right. So anyway, let's try these lines. So we have ground, and this should be 12 volts. Negative 12 volts. Wait, is that right? No, that's because I've got the probes around the wrong way. No, that's ground. 12 volts, and this should be 5 volts. That's a little bit high, but it's not under load, so possibly. And we'll try the other one just in case, but I mean it's the same. It's the same cable. So ground and 5 volts. That's dead on 5. And 12 volts, and that's dead on 12. Right. Well, so far so good. I want to see what this blue is actually. Is it a voltage or is it a sense cable? Who knows? We'll find out in a second. Well, possibly. As soon as I can find out how I can actually get some probes to it. I don't think that's touching. No, it's not touching. Oh. Minus 10. That's an interesting value. I don't know if that's right or not. Anyway, the power supply isn't buzzing. There we go, and we can turn that off. Right, so that seemed to be as near as damn it to the correct voltages. So I say we reinstall this chappy back in the machine. There's no smoke. The voltages seem to be correct, so I think we're okay plugging this one back in. Right, let's go and do that. Okay, so here we are at the machine, and this is all still disconnected, so we can just move this a little bit out of the way to make it easier for us. Hopefully without breaking anything, because you know, I prefer not to. And then we should just be able to push the power supply back in. Well, obviously that's the back. So which is the bottom? Oh, okay. Well, these must be at the top, because where else would they go? Oh, okay. No, never mind. We've got like a little chin thing here, and there's a point there where that'll go in, so we know which way this goes now. Excellent. That was easy. Let's hope it just wasn't the only easy bit. Right, so this should... Okay, so we'll probably have to... Oh, well, there we go. That's through. That's fine. So we should just be able to slide this in. It's going to go in there. Come on. Yes, there we go. Right. There we go. So that's connected. Now, let's get the power leads out of the way, because we need to reconnect this. And this is on like a little edge connector. So this might be tricky to get in. There's no real guiding lines for it. Oh, okay, we've got the... I guess we've got the screw. I guess we can line it up with that. And okay, well, hopefully that's in. Hard to say. Screws in place though, so odds on. Yeah, there's literally no way of telling other than that. I guess we can look from the side. No. Can't see really from the top either. Okay, we're going to have to hope for the best with that one, but we can now screw that back in. I really must get like a lapel mic or something. Because the sound quality definitely drops off as I move around. That's in place. It kind of needs the back to cinch it up a little bit, so let's go ahead and add the back in. Now, the issue here is I'm going to have to turn this around. It's not quite as heavy when the floppy drives out there, but it's still not. Actually, yeah, it is quite. It's alright. It's a lot less unwieldy once you've taken the drives out. Like the sword, the drives seem to be. Is that actually in place? That is in place, isn't it? Oh no, hold on. I've got these things at the back here. Come on, you need to come back out a little bit. Doesn't want to. I think these have to go over there. Oh, God. Come on, you must have been in there at one point. Okay. Oh, there we go. Right. These little clips over here had to go around this body shell. Now it's all held together properly. There we go. Right. So, I put the screws back in for all of this stuff. So we just take them all out. Right, now we put the back plane back on. Now we gave this a little bit of a rub down. It needs a bit more of just a brush over, but it's basically clean now. So we can position this over here. Okay, I guess that goes in there. Oh, how does this? Okay, that's it. Okay, right, that's it then. No, that's not it. How does that work? That needs to be up a little bit. Yeah, okay, we knew that was sagging, so that needs to... We're missing a bit or something. Right, that obviously needs to go there. This needs to go there. Okay, no, that's it. We're there. It's there. That's good. Right, so that's the back plane on. I think that's probably all we really need to add on immediately. I guess, well, we need to plug the wires, the cables back in anyway. There's quite a few cables that go onto different boards. I took photos, but I'm hoping it's obvious where they go. Our front panel. That's the speaker. So these are the cables we care about here. So I think that one goes in there. I'm going to go and check in a minute, but this one is a very short cable and it's the same colour as this one, so I'm guessing that goes in there. And then this one, same colour but longer, so I'm going to go ahead and guess it goes in there. Right, let's check the photos because we don't want to plug stuff in the wrong way. Right, well that's all plugged in, so it always sounds like a curse when we say it, but that's ready for a smoke test, so let's reposition the camera and see what happens. Alright, so yet again, take the Japanese converter plug. Plug it in. You see what happens. We're pretty sure everything's back in place. Alright, let's try turning the power on. And fans up. We've got a power light and a high resolution light. I am not seeing any smoke. Nope. Okay, I'm going to try turning this high resolution button off. Didn't seem to do much. Maybe if I reset it. There we go. I was about to tell. So there's absolutely some processing going on then. Right. I guess we try to get a picture then. So let's turn this off. Okay, so the problem with this is that it's a digital output on this machine. So it's not going to be really easy to do anything proper. But all we really want to do is see if there's any signs of life. And we can do that. We just need to work out which one's ground. Probably the middle pin, but it's not always. So we have our DIN socket here, which we can push in. There we go. And all we've got to do is work out which one of those is ground by using good old continuity mode. There we go. So there's our ground pin. I say that, you can't see that. So this here is a ground. It's used for grounding the case, and that's the only pin that has continuity. So that's ground. So there we go. As we look at it, the top right is ground. So knowing that, okay, so what you can see there is the test pattern from the RetroTink. Now we're not going to get a picture, digital logic, so it's not going to be able to drive this, but what we were trying to see is if the video signal is being raised, in which case that would suggest that something is powering it, which would suggest we're getting some signals. So let's turn the power on. Oh, we have a black screen. Again, I wouldn't imagine this is going to do much because it's not going to be a real picture, but there we go, no signal. And if I look at the display from the OSSC, it's getting a picture of something at 31.25 kilohertz. So yes, that's a picture. So it is indeed receiving some kind of video output, which would suggest that this machine is at least getting some distance into its boot process. Okay, so we know it's producing some kind of signal through the video port, but we obviously don't know what it is. It could just be a load of corrupted rubbish, or just something that's pulled it high. We don't know that. So one thing we can do, obviously we're going to build a proper cable at some point, but we need to work that one out still. But one thing we can do is we could just check the lines to see what signal's being produced. And to this end we have our mini scope here, and what we're going to do is connect it to the ground and to the, I think, one of the sync lines. I think the horizontal sync line, and we're going to just turn the machine on and see if we get a signal. Now remember, this is a digital output, so we're expecting very defined signals, not a kind of an analog signal. So if we get that, then we can be reasonably sure that something is happening. Oh, can you see that? I can't really zoom in much more, unfortunately. This camera isn't that great. But if you look, you will see that there are patterns going across the screen. Let's see if we can... Nope. Oh, wait. There we go, you can see them a bit better now. So, yeah. Now that, you can't see it quite as clearly, is what looks very much like a sync signal. Let me slow it down. This scope isn't great, as you can tell. There we go. There we are. Right. And as you can see, different bands of data with bigger pauses. That looks very much like a sync signal. And that's good. That means we are producing a proper video output, which is strongly shows this machine is certainly processing something, and that of course is what we want. So I've got, don't want to jinx it, touch wood, but I've got high hopes that once we get a video cable, we're going to see something on the screen. Unfortunately, will not be this episode, but we are getting there. Right, I think that basically wraps it up for this episode. I know it's another episode of this one, but we are definitely what looks like almost there. Hopefully, I mean. All the signals seem to suggest that we're getting a valid sync signal coming through that video port. Now, sometimes the video signals can just kind of work on their own, depending on how a machine is built. So it could be that whilst the video circuitry is all working fine, all the rest isn't. But I don't think that's the case with this one. I just get a hint that something is working on this, and maybe it's false hope, but I guess we'll find out. But anyway, that's it for this one. Next time we will we're going to try to build a video cable, so I probably won't do another episode until I manage to work out the video cable for this, which does mean me turning it on without... I'll record when I turn it on the first time, just so I have some footage of the first time it turning on, and obviously in case something happens, because you never know. So hopefully the next time we do a video, we'll be getting some kind of video output from here. And then that'll be kind of the main series done, because we'll have it working, but then we'll do more on this, we'll get some software running on it, we'll get a Gotek in there, and we'll clean up that case. One of my patrons has recommended T-Cut, and I've never tried it before, but is possible it might work. So the scratches on the lid of the X1, they aren't particularly deep, it's a metal case, so it might actually work. So I'm going to probably try that. That's Pete Golding suggested that one from my Discord. And yeah, it may work, because it's like I say, they're not scratching on deep, so we'll give it a try. If it works, it means to have to respray the whole thing, and that's a bonus. But anyway, thanks for watching. If you enjoyed the video, please hit like. If you really like the video, please hit subscribe. If you didn't like the video or you have something else to say, then please leave it in the comments below. See you next time.